Hello guys, welcome back to OpsByYash. Today I will be explaining you what is Docker and why was it created. So let's say you are a developer, you build an application on your laptop, you installed everything you need, Node.js, Python, Java, some libraries, a database, Redis, environment variables, and after 3 hours of debugging, it works perfectly. You are happy, you send it to your teammate, they run it and it crashes. They call you and say something is wrong with your application. You say no, it works perfectly on my machine. And congratulations, you have discovered one of the biggest problem in software development. But let's understand why this happens. Your application isn't just your source code, your application depends on its environment. For example, imagine your application needs Node.js version 20, a specific version of NPM, a particular Linux library, Postgres 15, Redis 7, and 10 different application dependencies. On your laptop, everything is configured correctly, but the testing server might have Node 18, the production server might have Node 20, but completely different Linux distribution. Suddenly the same application is running in 3 different environments, and that means you can get 3 different results from the same code. So the real problem isn't simply my code doesn't work. The real problem is my application environment is different. Now, one solution was virtual machines. We could create a virtual machine and install everything our application needed inside it. For example, Ubuntu, Node.js, libraries, application, great. Now the environment is isolated, but there is a catch. A virtual machine doesn't just contain your application, it contains an entire operating system. So if you have 10 applications, you might end up running 10 operating system, and every operating system needs CPU, memory, storage, updates, security patches, monitoring, and someone has to maintain all of it. Usually the DevOps engineer, and the DevOps engineer has already suffered enough. So engineers started thinking, why do we need an entire operating system for every application? What if we could isolate the application without creating the complete virtual machine? That's the idea behind the container. Think about a container as an isolated environment where your application can run. Inside that environment, you can have your application, its runtime, its libraries, its dependencies, its configuration, and the application gets a predictable environment to run in. But unlike traditional virtual machine, containers generally share the host operating system's kernel. That's the one of the reason container can much lighter than virtual machine. Now comes Docker. Docker is a platform that makes it much easier to build, package, distribute, and run the application as container. And here we need to understand two very important concepts: Docker image and Docker container. Let's make this extremely simple. Imagine you are making a cake. The recipe tells you exactly what ingredients you need and how to prepare the cake. That recipe is like a Docker image, and when you actually make the cake, that's like a container. So image is equals to blueprint and container is equals to running instance. You can create multiple containers from the same image. Now let's bring this into a real DevOps world. A developer writes code, the code goes into Git, your CI/CD pipeline builds the application, Docker packages the application into an image, the image gets pushed to the container registry, for example Docker Hub or a private registry. Then your deployment platforms pulls the exact image, maybe Kubernetes, maybe ECS, or maybe another container runtime. And the same image can move to development, testing, staging, production. So instead of saying please configure production exactly like my laptop, we are saying here is the exact artifact, run this. But I want you to go to one level deeper. Docker isn't magic. Underneath Docker, Linux is doing a lot of heavy lifting. Technologies like namespace helps isolate processes, cgroups help control and measure resource like CPU and memory. File system technologies help create the containers file system, and networking technologies allow containers to communicate with each other and outside the world. Docker basically gives us a much simpler way to work with all of this, and that's why learning Docker isn't about memorizing commands. It's about understanding what's happening underneath those commands. And now that you understand why Docker exists, let's make this practical. I am going to open a terminal and run just one command, docker run nginx. And we are going to follow exactly what happens, where does the image comes from, who downloads it, how is the file system created, how does networking get configured, how does Docker actually start the process, and what happens if something goes wrong. That's our next video, because running Docker is easy, understanding Docker is where things get interesting. So stay tuned with OpsByYash for the next video and subscribe to my channel.